All right. So for this first problem, we need to just memorize a demand curve for linear demand, right? So, we draw our axes QP, and then we want to draw the linear demand, right? So it's like this. Okay. And we want to find the x-intercept and find the y-intercept, right? So that's the first step. So we can find that by plugging, if we plug in q equals 0, we get that when q equals 0, p equals 80. So that's the y-intercept. And then similarly, when we plug in p equals 0, we get q equals 320. So that's the x-intercept. Okay. So the important point on a linear demand curve is the midpoint, the middle point of when kind of the two endpoints. So the nice thing about lines is the midpoint happens exactly halfway on both coordinates. So it's like halfway down from 80 is 40 and halfway down from 320 is 160. Okay. And the part you need to memorize after this is that the upper half is elastic. The midpoint is unit elastic. And the bottom part is inelastic. Okay. And so then we're just able to solve this problem, right? So we see when demand is elastic, when Q is greater than 160. So let's check, right? Q is 160 is here, greater than Q greater than 160 means to the right. So we look to the right and we see, oh, that's not the elastic, that's actually the inelastic region. So that's wrong, right? And then, we do something similar for the next one, right? Q is greater than 80, right? So 80 is like right here on the axis, right? And so, we see to the right, greater than 80, there's some part in the elastic, there's actually the part in the unit elastic, and there's some part in the inelastic region. So this one's not right either because it's actually all three of them. Demand is elastic when P equals 20. So P equals 20 is right here, give or take. And we map that over and we see, oh, that's in the inelastic region, not in the elastic region. That's wrong. And demand is inelastic when P is less than 40. So 40 is here on P axis, less than means down. And so that's in the inelastic region. That's correct. Number 2 is also something you need to memorize, which is that the monopolist will never operate in the inelastic region. And here's why. Okay. So that's going to be the first blank. It's going to be inelastic. That's where the monopolist will never operate. And the basic idea here is we show that we can always get a better profit. So remember, profit is, as usual, total revenue minus total cost. And if we think about the total revenue, right, total revenue equals price times quantity. Total cost is, well, we don't have a formula for this, but we know it's going to be based on the quantity, right? When I produce more, I cost more. When I produce less, I cost less, right? So that's going to be what we use. So for inelastic, what we know is that the quantity is not very sensitive to the price, right? So that means I can change the price a lot and it's only going to affect the quantity a little bit. Okay, so with that in mind, what if we raise the price a lot? And again, that's only going to affect the quantity a little bit. And which way is it going to go? Using the law of demand, right? When price goes up, quantity has to go down. And so it's going to go down just a little bit, right? So what's going to happen overall? Well, we have one big arrow, one small arrow. So the big arrow is going to win out in the end of the day. So the up arrow is going to win, right? So total revenue is going to go up. And what happens when quantity goes down? Well, as I mentioned just now, right? When quantity goes down, total cost goes down. So let's think about this in terms of profit. So the total revenue is going up, which is pushing up our profit. My total cost is going down, and it's negative. So like when a number that's negative goes down, that's bringing the whole thing up. So like, lower cost means more profit as well. So this is going to be a guaranteed way to increase our profits. And so that's why we can actually earn a higher profit by when we're producing the inelastic region by raising the price, right? So that's answer choice B. Number 3 is a learner index problem. So the way I know that is because it, in particular, it gives me a number for the elasticity of demand, right? And so we can use that to do the learner index, right? So learner index has 2 formulas. The one formula is 1 over the absolute value of the elasticity of demand, and the other one is P minus MC over P. Okay. So what does it give us in this problem, right? It gives us MC as 12. So it gives us this, and it gives us the elasticity. So if we just look at this formula, right, how many variables do we have? We know elasticity, we know MC. So our only variable is P. And so therefore we can just like plug in and solve for P, and then we'll get the answer. So we'd get P minus 12 over P equals 1 over 1.5. right? Don't forget to take the absolute value here. So we multiply both sides, we cross multiply. So we 1.5 P minus 18 equals P. Solve for P, we get P equals 36. Right? And so that's our P star. That's our profit maximizing price. And so we get answer choice C. Okay. For number 4, there's another learner index problem, and here it's much more explicit. It tells us that we need the learner index. Okay. So again, we have our two formulas. One is like this, and the other one is like this, P minus MC over P. So definitely the one that's going to be easier to use is the one on the right, and that's pretty much always going to be the case. So unless it gives us a number for the elasticity, and then of course that one's going to be easier to use. But in general, this one on the right is going to be easier. Okay, so the first step with any monopoly or with any firm is we do MR equals MC. Okay. So we have to get the marginal revenue here because it gives us the marginal cost. We just need to get the marginal revenue, right? And so the thing to know about the marginal revenue in monopoly, because it's linear demand, when you have the inverse demand function, you take the same intercept. So right now the intercept's 100. And you take the slope and you double it. So it's right now it's minus 2Q. So double the slope is minus 4Q, right? So that's how we get the marginal revenue. Keep the same intercept and double the slope. So we get minus 4Q, okay? And then so equals 16. Solve for Q, you get Q equals 21. And then now we just need to plug back in to get P, right? And we be careful here. You don't plug back into the marginal revenue because that will give you marginal revenue. You plug back into the demand curve, which will give you price, right? So if we plug back in there, we get P is 58. Okay. And so as I mentioned at the beginning, right, we're going to use that right-hand formula, which is P minus MC over P, right? P minus MC over P. So we get 58 minus 16 over 58, right? Which is 42 over 58, which is answer choice D. It's worth noting here, the learner index is always between 0 and 1. So it's not going to be A and C, like right away off the bat, we can tell that. So that's a good test taking strategy, just like eliminate what you know is not the answer. Okay, number 5, also learner index problem. So the introduction of satellite television systems should cause the learner index for cable television to blank, right? So the question here is really about, do you think the monopoly for cable television is getting stronger or getting weaker? And here we're introducing a substitute, satellite television is a substitute for cable television. So in other words, we're getting more competition, more competitive, less monopoly, right? So learner index is going down because it's less monopoly, more competition, right? So just in general, like learner index between 0 and 1, 0 is perfect competition, 1 is like perfect monopoly, and everything else is in between. So here we expect a decrease. We're adding in more competition. Okay. Number 6, this is the last kind of theory problem. So if the monopolist sets its output such that marginal revenue and marginal cost and average total cost are all the same, then what do we have to know about the profit? Well, really the main thing we need to know here, because we have ATC, is we need to be able to compare this to the price, right? Is it less than the price? Is it greater than the price? Is it equal to the price? That's what we are not sure, okay? And luckily we have one way to do that, because in monopoly, what we know is that price, if price is, this is what we just talked about, A minus BQ, it's like a linear demand. We have marginal revenue equals A minus 2BQ, right? Same intercept, double the slope. Okay. And if we write it like this, we can see clearly that the price is always bigger than the marginal revenue, right? They start at the same point. They start at A, but this one's going down at a rate of BQ. This one's going down at double the rate at 2BQ, right? So they start at the same point. This one's going down faster. So therefore, like P has to be bigger than MR, right? And so if P is bigger than MR, then P is bigger than MC, and then P is greater than ATC as well. And so because of all that, we know that we're making a positive profit because P is greater than ATC, right? So the answer here is positive profit. Good. So in number 7, we're interested in the actual profit. So this is like going to be an actual calculation problem. So like always, we start with, for every firm, MR equals MC. Okay, here they didn't give us either of them, so we have to find both. So MR, again, right? Same intercept, 100, double the slope, so 0.5 times 2 is just 1, so minus Q. Okay. Total cost. How do I get from the total cost to marginal cost? I take the derivative, so I get marginal cost equals 5. And then I just plug this in. 100 minus Q equals 5. Q star is 95. Okay. And then, so then we get P star by plugging it in. Again, we plug it into the demand function, not the marginal revenue function. And we get P star is 52.5. Okay. After doing this, it's just like in perfect competition where we do profit is total revenue minus total cost. Right? Total revenue, as always, is price times quantity. And if we multiply these two numbers, 95 times 52.5, we get 4987.5. Okay, and then so for the total cost, we use the total cost formula that they gave us up here, and we plug in the quantity, and so it's 95 times 5, and so we get 475. We subtract total revenue minus total cost, and we get A is the answer, 4512.5. Okay, good. Number 8 is very similar to number 7, right? So we find the marginal revenue. So same intercept, double the slope, minus 12Q. We find the marginal cost. So we get 120 plus 6Q. And we set them equal, right? So that's the first step as always. MR equals MC. Okay, so 300 minus 12Q equals 120 plus 6Q. We add the 12Q to the one side, subtract the 120 on both sides. 180 equals 18Q. So then we get finally Q equals 10. It's Q star. Okay. So to find the actual price that we have here, again, we plug in the demand curve and not the marginal revenue, not the marginal cost. We plug in the demand curve. Okay. And so we get 300 minus 60, which is 240. So that's the profit maximizing price here, 240. Okay. Now, number 9 and 10 are about deadweight loss, but they start pretty much the same way, right? So for deadweight loss, we have a few more steps, but pretty much the same beginning, right? So we find marginal revenue, same intercept, double the slope. Okay, we find marginal cost by taking the derivative. So we get 30 plus 8Q. We set these equal, MR equals MC. I'm just going to do it in my head here because, to save time. So Q star is 5. And to find P star, we plug it back into the demand function. So 100 minus 15, which is 85. Okay. So these are the same steps as the previous problems. Just, do it out, check your work. So let's draw out this problem. In general, with the deadweight loss problems, I would recommend you just draw it out. So we have our demand curve, which is looking like this. We have our marginal revenue curve, which looks like this. We have our marginal cost, which in this case is upward sloping like this, right? It's 30 plus AQ is an upward sloping line. And what did we just find, right? We found where MR equals MC. So that's how we got the quantity. We got a quantity of 5. And then we went up to the demand curve and we got a price of $85. Right? So remember, the deadweight loss triangle is the triangle directly to the right of this. So like right here, right? And so I need 3 points to find this, right? I just got one of them. I need this bottom one. In particular, I need the y-axis point at this bottom one. And then I need this one on the right. And in particular, I need the x-axis point on this one, right? So let's find this bottom left point first, right? So the bottom left point you can see is at the same quantity, Q equals 5, but you can see it's where MR and MC are touching. So you could plug Q equals 5 into either MR or MC. So here's where you can use MR and MC and plug in the quantity in those, right? And if you do that, you get 70. Okay, so I just plugged in Q equals 5 into MR and I got a 70, or you could plug it into MC and you get 70 either way. Okay. Now, this last point is something we haven't done yet, which is that And you can just see so use the graph to kind of guide you, right? The graph here shows you MC and the demand curve are touching there, right? So in particular, the demand curve is P, MC we already have, right? We got 30 plus 8Q. So we can just set them equal and solve for Q. That's how we're going to get the x-axis point there. So we do 30 plus 8Q for marginal cost equals 100 minus 3Q for price for the demand curve, right? So we solve for Q. We get Q is 70 over 11, which is like 6 point something. Okay, so we have 70 over 11. Okay, 6.36, I guess. Okay, and so then to find the deadweight loss, we just find the area of this triangle, right? So base times height times 1/2, right? So we do deadweight loss. So the base of this triangle is 15. The height of the triangle is whatever this is. So 70 over 11 minus 5. You can do that on your calculator, and then times 1/2. Oh, whoops, times 1/2. Okay, good. And you should get A. Okay, so for number 10, similar problem, right? So in this one, they just gave us the marginal cost. We can find the marginal revenue to be 100 minus 2Q. Okay, and so we get start the same way, right? MR equals MC. Okay, and again, I'm just going to do this in my head just to save time, which is Q star equals 45. Definitely do out the work though. And if we plug that in back into the demand curve, we get P star as 55. Okay, so again, we're just going to draw this out because we're trying to find the deadweight loss. So the demand curve, as always, looks like this. Marginal revenue, as always, looks like that. Okay, but in this case, the marginal cost is just equal to 10, right? So 10 is just a horizontal line. Oh, oops, let me try again. Horizontal line like this. Okay, and so we can what we just found is where MR equals MC, and so we can label this as 45 for Q, and on the demand curve we got 55 for P. So this is a little bit different from the previous problem. So luckily here, because MC is constant, we actually already know this bottom point. So we have to do a little bit less work. But if you want to check your work, you could always plug back in Q into the marginal revenue to make sure you get 10, how you're supposed to. Okay. Okay. So then the last thing we need is just this last point, the one on the right here, right? And so we get that by doing, as the graph shows you, set the demand curve equal to marginal cost. So we do P equals MC, right? Which is the P is the demand curve, which is 100 minus Q. And the MC was just 10. So we find Q, which is Q equals 90. Okay, and again, base times height times 1/2. So deadweight loss here is 1/2. The this leg of the triangle is 45. This leg of the triangle is also 45. And 1/2 times 45 times 45. Okay, good, which is answer choice B. Great. So hopefully this will help you with all multiple choice. The long forms are very similar. I'll let you try those, use that as practice. So yeah, and good luck.